lubrication of mechanical equipment is important. For example, we check the crankcase oil level periodically when getting gas for the car. If the crankcase were dry, bearings would bind or seize, and we'd have an expensive repair bill. As with your car, proper lubrication is of vital importance in maintaining trouble-free operation and in avoiding machine damage or equipment failure at your power plant. With the advent of larger size, higher speed, and higher temperature range equipment, the use of correct lubricants has become more important. The purpose of this film is to acquaint you with the basic philosophy of lubrication and various types and characteristics of lubricants. The purpose of lubrication is to separate moving, loaded surfaces by interposing an oil or grease film between the surfaces. This reduces friction, heat, and wear. The weight, shown here, is prevented from making metal-to-metal contact with the ramp by the oil or grease film. In this picture, a cross-section of a shaft in a bearing is shown. The shaft is not moving. Practically speaking, there is metal-to-metal contact. As rotation starts, first action of the shaft will be to climb up the bearing, as shown. At this stage, there's a sliding of metal on metal, and lubrication takes place by oil adhering to the metal. As shaft speed increases, the lubricant is dragged down until it forms a thin pad under the shaft, and film lubrication is established. The shaft now assumes a central position. Because of the oil film, the shaft is raised slightly in the bearing, as shown here. In this way, the metal-to-metal contact is eliminated. Full lubrication is achieved when the shaft reaches its operating speed. There are several types of oil used as lubricants in power plants. They are mineral oils, fixed oils, and synthetic oils. Mineral oils are produced from crude petroleum by refining processes. After separation, further refining deletes waxy compounds, which become solids at lower temperatures. Then it's filtered to remove foreign matter. After this refinement, different grades are blended or mixed together to produce the various lubrication qualities desired by industrial users. Fixed oils are of vegetable or animal origin and are usually called organic oils or greases. Vegetable oils are produced from seeds or fruits or plants or trees. Some of the more common are castor, olive, coconut, and peanut oil. Lard oil is commonly used as a thread or machine lathe cutting lubricant. One or more of these compounded with mineral oils form a steam cylinder oil lubricant, which will mix with steam and still lubricate well. Animal oils have very little value as lubricants when used by themselves. Synthetic lubricants are compounded from elements other than mineral and organic oils, and in many cases are far superior to petroleum-based oils. Generally speaking, synthetics have a very wide temperature range. One type of silicon synthetic oil will provide good lubrication from minus 40 degrees Fahrenheit to 300 degrees Fahrenheit. These lubricants are quite expensive, but are stable and long-lasting. As the quality of synthetics are being constantly improved, their use is becoming increasingly popular in special applications. An additive is a chemical compound which, when added to a mineral oil, gives the oil an ability to do a lubricating job which the oil alone was not capable of performing. Detergents maintain a clean internal surface in engines. Solids resulting from combustion are kept in suspension in the oil until filtered out or oil is changed. Oxidation destroys many lubricating properties of oil. An inhibitor slows this oxidation process. The use of inhibitors assists oil in providing better service for a longer period. When used with turbine oil, a rust inhibitor coats metal with which it comes in contact. This protective film acts to prevent moisture from reaching the metal surfaces. Oiliness and extreme pressure agents help to give even extremely thin films of oil better lubricating qualities and help prevent breakdown or squeeze out under heavy bearing loads. Grease now is a semi-solid which combines a fluid lubricant with a thickening agent. Density is designated by number. Number 1 would be relatively thin, number 5 quite thick or heavy. As with oils, many greases have been compounded for a specific application. 4 common types are designated on this slide. Calcium-based grease is suitable for use in the presence of water and is used as a pump packing grease. It is not suited for use, however, at temperatures higher than 180 degrees Fahrenheit. A soda-based grease, on the other hand, will withstand quite high temperature, but will wash away in the presence of water or steam. Lithium-based grease is called multipurpose because it is suitable for both high and low temperatures and has good water resistance. A synthetic grease is usually compounded for a specific use, but some cover a wide range of temperature with good results. One silicone synthetic grease will lubricate a ball or roller bearing through a temperature range of minus 100 degrees Fahrenheit to plus 350 degrees Fahrenheit. Synthetic greases are usually more expensive, but because of their versatility are usually worth the extra cost. Fillers are ingredients added to greases to give them a more stable body. Graphite is probably the best known filler. Lead, zinc, molybdenum, and mica are also used as fillers. Fillers help basic grease withstand heavier loading and protect bearings by forming a so-called solid film, which does not squeeze out during shutdown or shock starting. Viscosity is the term which defines an oil's internal resistance to motion within itself. It is considered oil's most important property. The most common method of expressing viscosity is the SAE rating, which stands for Society of Automotive Engineering. SAE 10 weight is a low viscosity or thin oil suitable for use in cold weather. SAE 30, on the other hand, is thicker and suitable for climates with temperatures to 90 degrees Fahrenheit. Higher viscosity means heavier body and more resistance of the oil to flow within itself. An apt illustration is attempting to pour molasses during winter. It is then very thick and will flow very slowly. The same molasses in July will be considerably thinner and will flow much more readily. Viscosity varies inversely with temperature, that is, viscosity of oil increases as temperature decreases. Because of this, the viscosity index for a given oil always indicates the oil temperature when viscosity was measured. Pressure also causes viscosity to change. An increase in oil pressure within a bearing will increase the viscosity of the oil. A lower viscosity oil has lower internal friction loss and flows more readily into close tolerances on high-speed machinery. As oil builds a fluid film around a shaft, pressure of oil within the bearing increases as shaft speed increases. This causes a viscosity increase, also an increase of the oil's load-carrying ability. In selecting a lubricant for a specific bearing, first the load is established. Then viscosity and operating temperature must be considered to prevent oil breakdown. Responsibility of the operator to make certain it's properly lubricated. Only the simpler features of bearing lubrication are discussed in this section. At your station, detailed information about your particular lubrication needs is available. Sleeve bearings, sometimes referred to as friction bearings, surround the shaft. Sleeve bearings are lubricated either with grease or oil. Slow-speed, heavily loaded bearings are usually grease lubricated, while high-speed, high-temperature bearings are nearly always oil lubricated. Turbine and generator bearings are high-speed, heavily loaded into the top of the bearing and in the direction of shaft travel. It builds a film to raise the journal, cool the journal as it passes through, and then returns to the reservoir. In most cases, oil passes through an oil cooler to dissipate heat carried away from the bearings. These bearings are fitted to the journal with minimum clearance and are lubricated and cooled by a rather low viscosity. Ring-lubricated sleeve bearings are lubricated by means of a ring around the shaft. The ring is larger in diameter than the shaft, and the bottom part of the ring is immersed in oil located in the bearing well. When the shaft rotates, the ring also turns, carrying oil up and depositing it on the journal. The importance of proper viscosity oil in a ring-lubricated bearing can readily be seen. If viscosity is too high, the ring may turn too slowly, or maybe not at all. Conversely, if the viscosity is too low, the ring may not be able to carry a sufficient amount of thin lubricant to adequately lubricate and cool the bearing. In either case, damage could very easily result. Ball and roller bearings are commonly referred to as anti-friction bearings. In this type of bearing, the only contact is the point contact on the balls or rollers. There's very little friction, and it's been said that the only necessity for lubricating a good anti-friction bearing is to avoid rust and corrosion within the bearing. Rust would pit moving parts and cause eventual bearing failure. When lubricating anti-friction bearings, care should be used. Fill the housing only 1/3 to 1/2 full when using grease, and only to the gauge mark when using oil. On anti-friction bearings in a very slow-speed installation, which is subjected to excessive dirt, it will be necessary to nearly fill the housing with grease to protect against contamination. Overfilling with grease may rupture the seals and will cause heat. Overfilling with oil will cause leakage around the shaft as well as causing excessive heat. Pay particular attention to this precaution. The two major types of couplings are mechanical and hydraulic. These are described in more detail in a later section. The mechanical coupling is oil or grease lubricated, and the revolving motion spreads lubricant over internal surfaces to reduce friction. The hydraulic coupling uses a turbine oil for fluid. In this case, the fluid is used to transmit energy from the driver to the pump, as well as to lubricate bearings. This oil is cooled with a water cooler. On this type of coupling, the operator has only to check and maintain correct oil levels. Periodically, oil samples are taken and analyzed to determine when replacement of fluid is necessary. Proper lubrication prolongs operating life of equipment and, of course, is a vital necessity. You'll obtain specific instructions about lubrication schedules, lubricants to be used, and procedures to be followed at your station. In order to avoid contamination, good housekeeping, as well as proper handling and storage of all lubricants, is of greatest importance. When cleaning oil storage tanks and reservoirs, do not use rags or other materials which will flake off and leave lint or fibrous particles. These particles will contaminate new oil when put into the tanks. Wipe all fittings clean before adding oil or grease. Hand grease guns should be arranged for filling by transfer pump wherever possible. Use only steel paddles on grease guns and receptacles which must be packed by hand. Wooden paddles may sliver. They also tend to collect dirt more readily. Always use the specified type or grade of lubricant. Your supervisor has a record of all lubrication specs. The best thing you can say is, if in doubt, check it out. Adding the incorrect lubricant could cause bearing failure. In many cases, unlike lubricants, are incompatible, and a mixture tends to destroy the better properties of each. When checking equipment for lubrication, note and report anything of an unusual nature, such as abnormal heat, vibration, or leakage. Okay, it's time to turn to your Tri-Media book and answer the questions in the self-check quiz on page 24. Restart the machine when you've finished. Slow-speed, heavily loaded bearings are usually grease lubricated, so question number 1 is false. Question number 2, true. 2. Number 4 is false, regardless of the month. The higher the viscosity, the heavier the body. Thus, the more resistance of the oil to flow within itself. One of the main advantages of synthetic oils is that they will provide good lubrication over a wide temperature range. So, number 5 is false. Wooden paddles may sliver and tend to collect dirt more readily. Number 6 is true. The next statement is true. Fixed oils are of vegetable or animal origin and are sometimes also called organic oils. For number 8, false. Ball and roller bearings are commonly referred to as anti-friction bearings. In this type bearing, the only contact is the point contact on the balls or rollers. Lithium-based grease will stand high and low temperatures and withstand water. Calcium-based grease is a water-resistant grease and will withstand temperatures to 180 degrees Fahrenheit. Soda-based grease will stand high temperatures but will wash away in water. An increase in pressure causes an increase in viscosity. Hence, number 10 is false. Particular emphasis was and should be placed on this statement. Number 11 is true. The answer to this question was given in number 4, but to repeat, viscosity is oil's internal resistance to motion within itself. It is considered oil's most important property. The answer, true.